Hello everyone, it's Landsat channel, and this is the start of series of videos about processing of satellite data in the quantum GIS. So this is first video where we try to obtain some satellite data and open it in quantum GIS. So, beginning with the resource where we could obtain satellite data. There are a lot of resources like that. It's QGIS Land Viewer, this is S Explorer and others. But the most convenient, for my opinion, is the Land Viewer from EOS. This service helps to find satellite data for the Landsat 8 and Sentinel satellites, download them and view them. So, for example, this is some territory, and shall we try to download some data. For example, I will try to download some satellite images for the part of Ukraine. So here, zoom in, choose Landsat, and we see all the scenes available for different dates. For example, I want to download this satellite scene for the 13th September 2016. We could preview it, we could zoom in. It's like Google Earth, I can say. Also, we could see different band combinations, like this is natural color, but also we could see some band combination for agriculture mapping, for example, as you see, that false colors, but they show better the state of farmlands. Or some vegetation with indexes like NDVI and others. But anyways, if we need to process this data in some more complicated ways, we need to download them and use some GIS. And I suggest to use QuantumGIS. So, how to download this data? We just press here download that button. We could download any of the spectral channels, but we need all the data, so we download Archive. Archive is like just here. We press download, then browser gives now us this window where we could save this file. I already downloaded it, so we shouldn't wait for it, and we could see it right here. So this is our satellite image. Then we unzip it with some archivator like 7-zip or WinRAR. Unzip it right there. In the folder, again, I don't do it, and we could see all our satellite data in just images, but they are separated into the bands. And next, we could also open it in the image viewer, but that's not necessary because that file, they are pretty big. So we need to open it in QuantumGIS. So we open QuantumGIS, of course. It's a clean installation of QuantumGIS, just a recent version of it, as you see, 2.18 version of QuantumGIS. And now how to open these raster images. There are a lot of ways to do it in QuantumGIS, but the fastest and simplest way is to press Add Raster Layer button. We press this button, we could open this folder with our files, and we choose our file. QuantumGIS reads a lot of raster formats, as you see. That's a long list. But if we choose all files, it's simply open right format. So we open our raster file and we could see our file. Of course, we could use another way to open this raster. We could use command like layer, add raster layer, or combination at the keyboard like Ctrl-Shift-R. But any way is acceptable for open raster layer. Then, what about navigation? How we could zoom in, zoom out? We could use for that our buttons here on the panel like zoom in or zoom out. We could use this pan button to pan around our image. but generally it's more simple to use mouse wheel to zoom in or zoom out, or to use middle button of our mouse to just pan around our image. So that's the main function about navigation in the QuantumJS. Anyways, if you open some vector data, anyways, we should use these buttons or we should use mouse. So as you see, we open our satellite image. It's pretty the same as we see in our browser window, but it's black scale. That's because that's only one channel, like channel 1. We also could open another channel, like channel 2, and if we press Ctrl, we could open another images, like several channels. But all these channels are there just black and white. They describe different parts of picture. So, if we need some color match, then we need to composite these bands, we need to pre-process it, so it looks like some satellite image. But about that we will talk in the next video. Thank you for attention. Hello everyone, this is Landsat channel and my name is Yaroslav Smirnov. In previous video we opened some bands of Landsat 8 image and navigate through them. And in this video we will try to composite this band so this satellite image become in colors, and also review some properties of raster image that we could change in the QuantumJS. So for the start, let me just remove all these bands that we opened in previous video and add them again. So we just select them and press remove in the context menu that we call by the right click on our mouse. So remove them and then add again by this button, add raster layer. For making some composite bands, we could open all the bands that are available for Landsat 8. That's bands from 1 to 7. But for convenience, we could change appearance of these bands by changing from all files to geotiff files. And we see no other files like georeferencing files, but only the bands like band 1, 2, 3 and other. So we select our band 1, press shift and select all other bands to band 7. Band 8 is Panchromatic band with the resolution of 15 meters. We don't need it for compositing because it's actually black and white. And this is some thermal bands and aerosol bands that we also don't need in our composite raster. So we select all these bands and press open. All these bands are open now, and now we need to composite them in one image. To composite bands, we could use a function raster in miscellaneous tools, and this function is build virtual raster or raster catalog. Press this button, we could select all the raster bands from Landsat 8 image by pressing select button, but we also could use visible raster for input. If we press this button, we could see here we add some program code. This program code is actually gdel command, which commands all the raster operation in QuantumJS. So we press this button to use all visible layers, then we select our output file, let's call it Landsat 8 one virtual raster, save it, and very important to check this switch to make it separate, because if they are not separate, all the band would be in one virtual band composed, and we could make it in colors like RGB image. So we select this separate option. Then we press OK, It's pretty fast. Processing completed. OK, close this window. And we see that we add some colors to our raster image. We could make all other bands invisible, or one by one, or it's more convenient to select all these bands and then just group it. So we're selecting them, pressing Shift, then choose here in context menu group selected, and then we make this group invisible. We could zoom in to our satellite image, and as we could see, colors are not right, because vegetation are blue. That's not how it looks like actually. So we need to make this in natural colors. If we open properties of this virtual raster, like with right button, press here context menu, properties, and in properties we could go to the style tab, where we could see all the bands of our image, like band 1, 2, 3 and other, that we make composite from them. And different band combination gives different colors. If we open Google and Google Landsat 8 band combination, here Google adds some suggestions. So natural color band combination is 432. Shall we try it? So red band we choose 4, green band 3 and blue band 2. Press OK. And we could see now that vegetation become green, as it should be. Agricultural land also become in colors that actually are good for them for September. And other colors are okay too. But still the image not looks so great. Because if we open Land Viewer again, we could see that in Land Viewer image looks much more impressive. Also, we could see that in the Land Viewer we also could review some other band combination, like band combination for agriculture describing, atmospheric penetration, and other. And these combinations are like 543, 652, and others. All these combinations also we could use in QuantumGIS, add them like manually. But also in QuantumGIS we need to enhance colors of our image. To do that, we open properties again, and we could change minimum maximum values of our pixels. We open this interface element, and we could choose, for example, for mean standard deviation, load these values, and we could see how these values are changed, like minimum pixel values and maximum pixel values. Apply them, OK, and we could see how changed colors at our image. But still it's not looks so great. So we try again, but now we also could clip extend to canvas. That made some clipping of our raster image. And if we try that and mean standard deviation, then load pixel values, press OK, and we could see that image looks much better. Much more contrast, much more brightness, and if we zoom out, we could see that all the image looks great. We could use that at creating some thematic maps, at creating some posters, or any other needs where we need some quality satellite images. Back to properties again. We also could change contrast if you like, change brightness, apply, OK. So we could enhance colors, contrast, brightness and other spectral characteristics of our image in QuantumGIS very easy with these options, like color rendering. We could reset it again, apply. Also we could change blending mode. It's like in Photoshop we could blend different layers together. Also we could do that in QuantumGIS with different layers. For example, we choose difference, apply, and we could see difference with this layer and background of our images. Again, back to normal, apply. Also we could change the sampling method. It's how different pixels are working with each other with different methods, but best to use nearest neighborhood. So that's the main process of creating some composite bands. And in this process we created our colorful image of our Landsat 8 satellite data. And in the next video we would create some pan-sharpened image to make greater resolution and also make some pre-processing to our raster image. Thank you for attention. Hello everyone, this is Landsat channel and my name is Yaroslav Smirnov. In this video we would make some clipping of raster image and especially this Landsat 8 image. In the previous video we created some composite bands of our Landsat image, but Landsat images are big. They are squares 180 by 180 kilometers, and usually such a big size is not necessary, and for making processing of Landsat data faster, usually it's clipped. Clipping could be done by some extent in the coordinates or by some vector layer, but using vector layer as a mask for clipping is much more convenient. So we're adding some vector layer here with the button Add Vector Layer. I use this region file, open it, and you could see that it covers some part of our image. And this part of the image would be our main image for other videos, for classification and pan-sharpening. So how to do this clipping? For this we use GDAL tool, which called Clipper. Here you see raster, extraction, Clipper. We open this window, Clipper. We here see this command, GDAL translate, and our input file. Our input file would be our image Landsat 8.1. Output file, just add this file name, Landsat 8, and it is multispectral image, so it would be multi. Okay, save. Then no data value. No data value, this is these black pixels around the image. We would also have these black pixels right here, here, and we don't need them, so better to use no data for them. So pixels with value 0 would be no data. Then clipping mode. Clipping mode could be extent in coordinates or mask layer. We would use mask layer. Mask layer, we have region layer. Then create an output alpha band. We don't need that, but we need crop the extent of the target dataset to the extent of the cut line. This is convenient because we don't need such a big extent as for the whole image, but only for the part that would be clipped. Then we keep resolution of input raster and load this raster into canvas. Here our GDAL command. If we need, we could execute it from another application or from the Python console, but from Quantum GIS it's working fine too. Press OK. This takes some time, but it's pretty fast to make this processing. Close this window, and we see that we have our clipped image. We could make invisible all the Landsat 8 image and just see how looks our clipped image. Colors are not right, because as we remember from previous video, we need to make some band combination for natural colors. So we open properties, then red band would be 4, green band 3, and blue band 2. This band combination stands for natural colors. Also we could change minimum maximum values of our raster, use mean standard deviation, and clip extent to canvas. Load these values of minimum and maximum pixel values, press OK, and we have our clipped image. This is not a virtual image like we created in the previous video. It's a real TIFF file, but it's small, so it's very fast to process. And next task that we need to do is to make some pan-sharpening. but about that we will talk in the next video. Thank you. Hi everyone, this is Landsat channel and my name is Yaroslav Smirnov. In this video we make some pan-sharpening of our Landsat 8 image. In previous video we clipped this image to make it smaller, but the resolution of this image, this multispectral image, is 30 meters. We could measure it if we like. We just could use this measure instrument, measure line, and measure one pixel. As you see, this pixel is 30 meters. But also, if we open a raster layer and we open a band 8 of our Landsat 8 image, we could see that it have another resolution. This is Panchromatic image, it's black and white, but it have a resolution of 15 meters. We could measure it if we like, and we see here is 15 meters. So it's double is better than our multispectral image. And we could see just by looking. You see this settlement, how much more details in this panchromatic image. So general idea of pan-sharpening is to merge these two images. Merge this color image with this black and white image. How to do that? First of all, we need to clip our panchromatic band. We clipping like in previous video using raster, extraction, clipper tool. Choose our band 8. Output file would be our Landsat 8 image, but panchromatic band, save it, then use mask layer, region layer, no data value would be 0, crop the extent, and OK. So we clipped our image, we could make invisible all the band and have only this small part of our image. Then, next for pan-sharpening we could use several tools. It could be grass GIS tools, it could be Saga GIS tools, or Orfeo Toolbox tools. I prefer to use Orfeo Toolbox tools because it's very integrated into QuantumJS and works very fine. But you need previously to install Orfeo Toolbox, and you do it from the OSGeo installer. And when you install it, you could watch processing options and to check if Orfeo Toolbox tools in Orfeo Toolbox application folder there is a path like C program files. Orfeo Toolbox and command line tools of Orfeo Toolbox in QuantumJS bin folder. If you install Orfeo Toolbox properly from the OSGeo installer, advanced installer, and put this path in the processing options, then you have all the Orfeo Toolbox instruments right there. The general idea of pan-sharpening using Orfeo Toolbox is to first of all create a match resolution of two images. So when we have our multispectral image with the 30 meters resolution and panchromatic raster with 15 meters resolution, we need for pan-sharpening just two rasters with 15 meters resolution. To make resolution of our multispectral image from 30 meters to 15 meters, we could use some tool like Superimpose Sensor. We open this tool, our reference input would be our panchromatic band, so Landsat 8 pan, and image to project would be our multispectral band, Landsat 8 multi. Other parameters could be by default, except interpolation method, because this is BCO, bicubic interpolation. It's very slow, but it gives perfect result. But for this task we could use nearest neighbor, we don't see much difference, and nearest neighbor are faster. Other parameters could be by default either. Then we choose our output image. I suggest to name it like super tip, so it would be our superimpose sensor. I wouldn't run this now because anyways it takes some time, from 5 to 10 minutes to process this image from 30 meters resolution to 15 meters. So to make it faster, I already done that. I already have this super TIFF file and use it in our Panchromatic process. So, how to do Panchromatic? Our toolbox has 3 algorithms for Panchromatic: bias, LVVM, RCS. Well, we could use RCS or any other of algorithms, they are the same in the workflow. So, input pan image. Our input pan image is our Landsat 8 pan image. Input XS image, this is our multispectral image, result from superimposed sensor. We need to open this file, this one file, algorithm, only one option for algorithm, available RAM could be by default, output image, save to file, and let's call it like Landsat 8 15 meters. So we know this is Panchromatic image. Save and run this tool. This algorithm also takes some time for the processing, but it's faster than superimposed sensor. And we see our result. As you see now, here is the black area of our pixel with 0 value. There are no data, and we see that colors are distorted. So, to make it look better, we again change our band combination to natural colors like 432, load values as we do in previous videos. Yes, ready. And also we could make some transparency for our no data. So we make here add values manually, and for values when 0, 0, 0, this is black area, we make them 100% transparent. Okay, let's see what we got. So I think we not change there again, right there, because we loaded another values and it didn't work properly for the first. Try it again, load values for standard deviation, okay. And now we see our Panchromatic image. We could check is everything alright. We could also see how it looks like. You see there are much more details in these settlements or any other parts of the image. So Panchromatic image looks better. We could also measure our pixel if we like, right there, using our measure line tool. And we see here is resolution of 15 meters, like our Panchromatic band, but also here is all the spectral bands. So we make our Panchromatic, and using the Panchromatic image we could make some classification, digitization, or any other procedures of processing our satellite data. Thank you. In the next video we would make some classification. Hello everyone, this is Land.js channel and my name is Yaroslav Smirnov. In this video we will try to perform manual classification of satellite image data. First of all, let's open satellite image that we prepared in previous video. So we press Add Raster button and choose our Landsat 8 15 meters image that we made Panchromatic in previous video. Open it. As we see, this image not in natural colors, but we could easily change it. Zoom in, open properties of this image, go to Style, then change red band to band 4, green band to band 3, and blue band to band 2. Okay. Also we could change minimum maximum values of our pixels, choose mean standard deviation, clip extend to canvas, load these values, apply, OK, and now we see a nice Landsat 8 image in natural colors. Also we could get rid of these black pixels around our satellite image. For that we open properties again, go to transparency, then add values manually, and all the pixels with values 0, 0, 0 should be 100% transparent. OK. Now we proceed to manual classification of our satellite image. The main principle of this classification is just creating vector objects of the features that we recognize on our satellite image. For example, we recognize here some settlement, here some agricultural land, here some forest, here some water bodies. But first of all, we need to create vector object where we would digitize all these features. To do that, we press button New Shapefile Layer. New Shapefile Layer, choose a type. For manual classification of satellite data, usually using polygon type of shapefiles. File encoding could be any encoding, but usually it's UTF-8 encoding. And coordinate system, you should choose coordinate system of your satellite image. This is Landsat 8 image and its zone UTF, zone UTM 35. So we choose this coordinate system, but if your data in another coordinate system, you should choose that coordinate system. Okay? Also, we need to add some attribute fields. Let's add attribute field class text with length 10 symbols. Add this field to list. Okay. Now we save this shapefile, name it class. I already do that. So I override this shapefile. And we see here in our layer panel our shapefile class. Next, we start digitizing of this shapefile. To do that, we press here toggle editing mode and choose here add feature. And start digitizing features that we recognize on our satellite image. Let's digitize this forest. So starting from here, we put in some vertices around our forest. QuantumJS gives some error right here because he thinks that this polygon would intersect this vector data, but if we proceed in vectorization, this error would disappear. You see, there are no error now. So we digitizing this polygon and completing by pressing right button of my mouse. Class would be forest. Okay, and we digitized our first object. Next, we want to digitize, for example, this water body, this pond or lake. Again, digitizing its contour. Very simple. Press right button and name this class water, for example. Okay. Now we see some problem because we have two different entities right here, forest and some water body, but they have same color. So we're saving our editing results, then off editing mode and open properties of our layer. Then in style tab, we choose single symbol visualization option to categorized. Choose our column class, classify values, and for forest choose some green color, any color we like, and for water choose some blue color. Okay, and all other features that would be created, let it be some red color without transparency. Okay, okay. Now everything is fine. Next, what if we want to digitize some agricultural land? For example, this field. To do that, we again toggle our editing mode, choose our add feature, but what if we don't want to digitize all this border of this forest because we already have it? Then we must choose some option like autocomplete polygons. To enable that, we go to Setting, Snapping Options, choose Advanced Mode, and choose that layer class should be snapped by vertex and segment. For example, let it be 10 units, and avoid intersection. Then we begin digitizing. To do that, you see when I put cursor right here on the vertices or on the edge, it changed color. That's because activated snapping mode. So from these vertices, I start digitizing this field. You see I go through this water body and just digitizing this agricultural field. Right there. And then I don't need to digitize all this contour precisely. I just put some random vertices and complete my polygon. Name it agro, for example, okay, and you see all this border are already created by the program. Very simple. Again, same result of our editing, and you see we classify some part of this satellite image. We have some forest, we have some agricultural land, we have some water body. What we can do is this result of classification. For example, we could calculate area for every feature. To do that, we open attribute table, then we choose here field calculator and create new field area. Then right here we choose geometry area, okay, and we have area of each feature in square meters. What if we want to have area but in hectares? Again, it's very simple. We just update existing field, area, add this field right here from fields and values, area, but divide it on 10,000. So, divide on 10,000, okay, and we have area of each feature in hectares. We could label each feature using here labels button or here label. Show labels with this layer, label with our area field. So here we see labels for each feature of each area. So in this video we describe manual classification of satellite image data. In the next video we try to make some automated classification of satellite data using unsupervised and supervised techniques. Thank you for attention. Hello everyone, this is Landsat channel and my name is Yaroslav Smirnov. In this video we will try to do some unsupervised classification of satellite image data. In previous video we do it manually, but as you understand it's very hard to manually classify all the satellite image, because it's a great area and usually it's hard to manually digitize a lot of objects. So there are a lot of automated techniques, automated classification techniques in remote sensing. But they divided on unsupervised and supervised. Difference is that unsupervised technique is just you say for the algorithm how many classes you need and it performs classification. In supervised classification you also show algorithm how it looks at each of the classes. How looks some forest, how looks some water bodies, how looks settlement on the satellite image, and that algorithm perform classification. So here we try unsupervised classification. QGIS don't give a lot of options for the unsupervised classification, and generally unsupervised classification could be only performed with Orfeo toolbox. We already use this toolbox when we done some Panchromatic, and now we try to make some unsupervised classification. First of all, we need to make sure that our Orfeo toolbox is working properly, so we open processing options and see that our provider's Orfeo toolbox is active. It activated, and here we see some paths to Orfeo toolbox. That means it's installed and it would work. Okay, now we open Orfeo toolbox in processing toolbox, and here learning, we have a lot of learning algorithms. This learning algorithm is for supervised classification, train image classifier for different vector data, image classification supervised, and also here we see some unsupervised come-ins image classification. We open this tool, then input image. Input image, it could be our Panchromatic image, but mostly for automated algorithms, Panchromatic images are not the best choice. That's why we better open our set image with 30 meters resolution, multispectral. We even could not change our band combination because our unsupervised algorithm, they don't care about band combination, it uses all the band in our satellite image. So now we choose our Landsat 8 multispectral image, Another parameters we could leave by default, but when you would performing actual, real classification, you could try to change these parameters to gain the best result. But now we could change only a number of classes. There are 5 classes, but more classes, the more precise classification would be. So, for example, let be 10 classes and output image, save to file, and let's name it Unsupervised. Save. So it would be our classification result. Then press Run button and wait until algorithm works. You see it's very fast, and we have our classified image. Making visible our class layer, making visible our multispectral layer, and now see what this classification result looks like. To do that, we need to change style of visualization of this image, because now if we open properties, we see that it's styled with single band gray, and it's make no sense because we have 10 separate classes, 10 discrete classes. In QuantumJS it's a little bit tricky to visualize categorized rasters, because we need to choose single band pseudo color, and then we need to load our band values. It should be discrete interpolation, maximum value 10 as we remember, minimum 0. Then we choose equal intervals for 10 bands. And now program assigned for each band each separate color. Press OK. And we need to again classify this discrete image, equal interval, 10 colors. Apply, and let's see. Yes, we have each color for each of the class, and we could see that water bodies are classified perfectly well. That's that color, I suppose, but we could arrange it better. We could, for example, remove another values, another classes, and to see only our water bodies. Again, open properties. Let's make this layer transparent, this class perfectly transparent, and make this class also transparent to see how it looks like. And we see that we have classified our water bodies, and they are classified pretty good. As you see, it's classified by entirely. So if we need some water bodies, we could choose unsupervised classification. But for classification some other entities, we could, for example, classify some settlements or forests. It wouldn't work so well. That's why we need to use another classification techniques with different parameters. And for example, it could be some supervised classification. And supervised classification would be described in next video. Thank you for attention. Hello everyone, this is Landsat channel, and my name is Yaroslav Smirnov. In this video, we will try to perform some supervised classification of satellite image. In previous video, we tried to do some unsupervised classification and classify all the water bodies. But what if we want to classify forest and to do it more precisely? For that, we can do some supervised classification. There are a lot of options to do supervised classification in QuantumJS. We could use Orfeo toolbox using training image classifier and then image classification tool. Also, we could use some plugins in QuantumJS. I suggest to use plugins because it's a lot simpler than training classifiers and gives pretty good results. So open plugins, manage and install plugins, and let's search for plugins that do classification. Name it class, and we here see some classification plugins. The most powerful classification plugin is the semi-automatic classification plugin. It has a lot of options, it gives a lot of possibilities to classify, punch sharp, prepare a lot of satellite image, including Landsat 8 image. But what if we need simple classification without a lot of options? For that, I suggest to use the Tsaka classification tool. It's really great. Let's install this plugin, close it when it is installed, and this plugin it could perform supervised classification in very simple algorithm. So here we see interface of this plugin. Here it's settings, we could open it and see it has several classifiers. It's Gaussian mixture model, random forest, SVM, and nearest neighbor. Let's test default algorithm for classification and how it works. First of all, we need to choose our raster image. We have several raster images. Let's try Landsat 8 multispectral raster images that we created in previous video. Next, it's our vector layer. It's our reference classes. We could digitize it from scratch, or we could use our results of manual classification. We have here some forest, some agricultural land, and some water body. Only make result of our unsupervised classification invisible. So we could use this as our training classes, but this classification tool, it needs some field for our classification values, and it should be integer. So that's why we open our vector layer, then we go into editing mode, again open attribute table, add some new field, not a feature, we add in new field, and name it our class column, class 1 for example. Okay, and forest should be 1, agricultural land 2, and water bodies 3. So we just separate integer values. Save it. And now we choose here class. Here we must choose our class 1 field. We don't see it because we don't reload our layer, so we remove it. Okay, and add it again. Our class layer. Okay. The symbology of this layer it's not preserved, but we don't need it actually. So we choose class 1, and now we save our new file. Let's call it supervised, because it's supervised classification would be. And press this button to perform classification. Again, it's very fast, and you see result of our classification. You already see that we here have classified all the forest in pretty great accuracy, but let's try to see how it looks like. So we could make this layer invisible and see that all the forests are classified. Also we could change our classified layer a little, so it even looks better. So open it, properties, then again change to single band pseudocolor. Here we see we have 3 classes from 0 to 2, okay, discrete, and it should be equal intro for 3 classes. Try to classify it manually, or we could do it not manually and just value 0, value 1, value 2. Let's try that. Okay. And all the forest, it's our value 1. All the other entities are value 0. And also we could add another value, for example value 3. Try it. And all the water bodies would be this value. We could change colors. Water bodies should be blue, even more blue. Okay. Then second value we could change some color also. It's also water bodies. Forest, it should be green. Okay. And all the other values, it could be transparent. Okay. Okay. So now we see our result. Also we could make transparent all the other values that we don't need, and left only forest and only water bodies. and see how precise our classification. So water bodies, it's pretty great classified. All the green areas, all the forest, also classified pretty good, but as you see in the settlements there are also a lot of pixels. That's because there are actually some vegetation on these settlements, and that's why it classified. But anyways, result of classification are pretty good, so we could use it for some area calculation, some visualization and other purposes. So that's the general idea of supervised classification. We just choose some reference classes and then perform some classification algorithm. Like that we use Gaussian mixture model, but we could use any other of the algorithms. That's the idea of supervised classification. Thank you for attention. In next video we will try to export results of our classification. Hello everyone, this is Landsat channel and my name is Yaroslav Smirnov. This is last video of this series of video about processing of Landsat 8 data. And in this video I suggest to try to publish results of our classification. Publishing of data in QGIS could be done in two ways, generally. It could be done with print composer, like creating some print maps, raster maps, or it could be done like export in some more interchangeable formats, like Google Earth KML or some other formats like that. So first of all, let's try to make some printable map of results of our classification. Here we see button make new print composer, press it. Here we could name this print composer or just press OK, that would be fine too. Then we need to add our map. To do that we need this button add new map, very simple. So just put the area for our map and we see all the visible layers right here, how they look. In print composer there are two main buttons. This button for select move items. Item, it's a map, it could be some text element, some picture and other stuff like that. And also very important button is this move item content. If we use this button we could move our geographic area here, we could change scale with our mouse. Also we could change scale right here at the item properties toolbar, right here. Here we see that scale is 180 thousandths. We could make another scale if you like. Also we could make this image change its size if you like. So like this, we change size of our image. Also we could change scale of map right here, make it more round. Yeah, ready. So this is working with print composer. If we want to just export our map in some raster format like JPEG. We also could turn off some layers. For example, we want to turn off our supervised classification result layer and just to export our satellite image, our Panchromatic satellite image. But I don't off it. I'll try again. Okay, and now we need just to refresh our image and we see only our satellite image. Then we could export it in the raster format like this. Export as image. Also we could export it like SVG format or PDF. Export as image. Let me do some test JPEG. And set DP, that's fine. Save. And we could see how it looks like, our test image. That's only our satellite image. Also we could export two maps if you like. We could just make another size of our composer, our map window. Then we could copy this and paste again. And here we have two maps, as we see. And for this map we could change scale also to make it again more round. For example, not that window, sorry, for that window. Yes, so we change scale for this map. And now we need to lock layers. Lock layers, so it would be changed. Then we could go again to QuantumGIS, turn on another layer, for example, results of our supervised classification, and try just these results of classification to visualize right there. And we have here, again, log this layer, we have scale, as on this map, and we have this map with two different satellite images, with our actual satellite image and results of our classification. And again, we could export it with another name like test1, save, again 3000 dps, save it and see how it looks. So we here, right here, see two maps. But if we want to export it to some format like CAML and open in Google Earth. To do that, we need first of all convert our raster image to vector format. That could be done with raster, conversion, and polygonize raster to vector. Then we choosing our raster that we want to make vector. For example, it will be our supervised classification result. Name this file. Let it be our supervised file, save, and press OK. It will take some time converting, but like this we here have our vector layer converted with raster image. And what if we want to export in CAML format only our water bodies that classified? To do that, we need to delete all other items that are not water bodies. So we just select them, or we could just select all the water bodies and export them. I try this way, so I just find them in attribute table, select them, all the water bodies with the digital number 3, and then with the right button I use buttons in the menu, I press Save As. Save As, save only selected features, it's important, and format, keyhole markup language, CAML format. Then file name, I put right here file name, let it be file name test, OK. And other parameters could be by default because it's CAML formatted in QGIS 84, but also we could choose QGIS like this, coordinate system, simple default QGIS 84. And other option could be just by default. Okay. So we exported this in vector format and let me try to open it in Google Earth. File, open, and find this layer, test layer, okay, zoom in. And we see that all our water bodies now opened in Google Earth. You see that results of classification not so great, but according to the 30 meters resolution they are fine, and the most valuable thing is that automatic result of classification, so we don't do this manually, but automatically recognize all the water bodies. So this is how to export some results of classification in QuantumGIS. Thank you for attention.